All right, today we're going to solve some radical equations. Solving radical equations has a couple of simple steps. Step one is to isolate the radical on one side of the equal sign. Radical on one side, everything else on the other side. So if there's a number there that's outside the radical, adding to it, subtracting from it, multiplying it, whatever, you need to get that number to the other side of the equal sign. So you're isolating the radical the same way you've isolated just an individual variable. Step two, you have to eliminate that radical by doing the inverse operation. We always use inverse operations to solve equations. So the inverse of a square root is to square both sides of the equation. You remember in the last lesson or two, squaring a square root eliminates the radical, and all you have left is the radicand. Step three, solve whatever you have left. You're going to have some sort of equation left that might require some steps to solve. Depends on how complicated your equation is. And step four, which will not apply to us here, because all of our equations will have real number solutions, but step four should be to check your answer, to make sure that the answer doesn't make the radicand negative. It's possible when you do this to get an extraneous solution, one of those solutions that doesn't solve the equation, doesn't actually answer the question, because when you get your answer sometimes, you'll end up with putting it back in to check your answer, and you'll find out that you have a negative number as the final number inside the radicand. And you know that you can't take the square root of a negative number, so you would end up having no solution. So normally, checking your answer is what you're going to have to do to make sure it doesn't make a negative radicand. In this case, when you work on the skill today, all your answers will be real solutions. You won't have to worry about that. But that is an important step in solving these equations. So let's take a look and see how they go. Got a couple of easy ones to start you. 6 is equal to the square root of d. The radical is already isolated, so I'm just going to square both sides. Square this side will eliminate the radical. Square this side. So the left-hand side, 6 squared is 36, is equal to radical eliminated. All I have left is a radicand, d. And I don't have anything to solve. My final answer is 36, and I'm done. Square root of n is equal to 1/6. Radical is already isolated. No work to do there. So now just square both sides. And when I square left-hand side, the radical is eliminated. Square root of n squared is just n. And I square 1/6. Be careful when you square 1/6. Squaring 1/6 means multiplying 1/6 by itself. So it's 1/6 times 1/6. It is not 1/12, which would be a very common mistake. It's 1/6 times itself. You have to square the numerator and square the denominator. So you'd end up with 1/36. 1/36 would be my answer. 1. And I'll write it the way you had to put it into the IXL answer. They had to use the slash. They don't give you the fraction tool on this. But notice they say write your answer as a fraction. If you do it on the calculator and write it as a decimal, it will mark it wrong. You need to put your answer in the form that they tell you to. All right, let's look at a couple more. Once again, radical is isolated. Everything under the radical here, and there's nothing else on this side of the equal sign besides the radical. But before I do anything, I just want to use a little bit of number sense here. -2y is what's under the radical. Well, the number inside the radical has to be a positive to be able to take the square root. Therefore, -2's got to multiply by a negative number to make that positive. My answer for y is going to be negative. It doesn't make the radicand negative. The variable times the -2 will end up making the radicand positive. So I know that when I finish solving this equation, my answer is going to be negative for y. I'll square both sides. Radical canceled out by the square, so I just have -2y. And that's equal to, right-hand side says 2 squared, 4. Now I have a one-step equation to solve. It's simple. One, divide both sides by -2, and y is equal to -2. There we go. So -2 times -2 gave me +4 inside the radical, and the square root of 4 is 2. All right. Radical is isolated because this +16 is inside the radical. So I don't have to do anything. I'm ready to square both sides. If that +16 was outside the radical, it would be a different story. Square both sides. 15 squared is 225. is equal to z plus 16. And now I have a one-step equation to solve. I have to subtract 16 from both sides. 225 subtract 16. Z is equal to 209. Okay. You can check it. 209 plus 16 is 225. Square root of 225. Yeah, that's 15. Good to go. Now I have some radicals that are not isolated. 4 is equal to 9 minus the square root of n. So I need to get rid of this 9. I need to subtract 9 from both sides. If I subtract 9 from both sides, I get negative 5 is equal to the negative square root of n. Well, there's still a coefficient here. That coefficient is negative 1. So divide both sides by negative 1, and now it'll say positive 5 is equal to the square root of n. Now I have isolated my radical. So I had to subtract the 9 and then divide by this negative 1 coefficient. And now I'm ready to square both sides. My radical is isolated, so I'll square both sides. And when I do that, left side 25, right side n. Already got my answer, nothing to solve there. And it's 25. Same thing here, 5 plus square root of t. Well, square root of t is not isolated. You get rid of this 5, so I'm going to subtract it from both sides. So I'll get the square root of t, this time it was positive, so I don't need to put anything out here. It's positive, is equal to 5. And now square both sides. And now it looks just like the last problem, except different variable, that's all. Square that side. Square root of t squared is just t. And 5 squared is 25. And there's nothing to solve. Once I square both sides, I got my answer. Because my radicand was just a variable. Anytime the radicand is just a variable, once you square both sides, your final answer. You might have to do a bit of work to get the radical isolated, but then after you square it, you're done. All right, and now we'll do some complicated ones. Isolate this radical first. I need to eliminate this 56, so I'll subtract it from both sides. So now I have the square root of v minus 63 is equal to, I subtracted 56 from both sides, 68 minus 56 is 12. This minus 63 is inside the radical, so now my radical is isolated. I'm ready to square both sides to eliminate that radical. Square, square. So v minus 63 is equal to 12 squared, which is 144. And now I've got myself a one-step equation. Just add 63 to both sides. 144 plus 63, v is equal to 207. And the last one, negative 5 minus square root of 3v plus 12 is equal to negative 20. So I'll start by getting rid of this negative 5 by adding 5 to both sides. That gives me the negative square root of 3v plus 12 is equal to, add 5 to this and get negative 15. I need to get rid of this negative by dividing by negative 1, because that's a negative 1 coefficient. So I divide by negative 1. I still have the square root of 3v plus 12, but now it's equal to positive 15. And now I'm ready to square both sides because my radical is isolated. This 3v plus 12 is all inside the radical. So go ahead and square this side and square this side. And 3v plus 12. Notice that my radicand didn't change. The square just eliminated the radical. It didn't change what was inside. Is equal to 15 squared, which is 225. Now I've got myself a two-step equation. Simple to solve, though. Subtract 12 from both sides. So 3v is equal to 213. And then divide by 3, and v is equal to 71. V is equal to 71. That's how you solve radical equations. Go ahead and give it a shot.